In this video, we'll talk about solving absolute value inequalities. So the difference between absolute value inequalities and absolute value equations is that when you're writing two inequalities, you'll need to have to determine whether or not the compound inequalities should involve the word and or involve the word or. So my suggestion is always to draw a graph before solving to help determine the and or the or. And then eventually you might see that there could be some shortcuts that you might take. But once again, we want to always be conscious of what the statement is telling you and not just kind of blindly go through steps. When you blindly go through steps and don't think about what the equation is or inequality is telling you, you might miss something very important and come up with an incorrect solution set. All right, so let's start with a simple absolute value inequality. So we see an absolute value symbol, we see an inequality symbol. So this statement tells us that the absolute value of x is less than or equal to 5. Now that means that the value of x could be equal to 5 units away from 0, which we saw before. If we're equal to 5 units away, we're either at 5 or negative 5. Or the distance from 0 can be smaller than 5 units away. So I would be also thinking about any of the numbers between negative 5 and 5 because those are closer to 0 than 5 is. So in the picture you see that we're translating this absolute value inequality into a compound inequality. So this compound inequality says that negative 5 is less than or equal to x, which is less than or equal to 5. This is an and inequality because we want to be both bigger than negative 5 in absolute value and less than 5, positive 5 in absolute value. So the question that I asked below is, we in this case have less than or equal to, but what if we replace that less than or equal to with just a less than? What would that change in this picture, and what would that change in this and inequality? So if we replace the less than or equal to with just a less than, all that does is it takes out the possibility that negative 5 and positive 5 are solutions to this statement. In the compound inequality that we see here, we would have strictly less than for each of these inequalities. We would not have the case or equal to. So we would have parentheses at each of these endpoints for our interval. So this means that if we're looking at an absolute value inequality with less than or equal to, or just simply less than, we could translate that into an and inequality. So in general, if we don't have just one variable x, but we have some sort of algebraic expression, u, so that u is less than or equal to a in absolute value means that the expression lives somewhere between negative a and positive a, or anywhere in between. It could be equal to those endpoints if we have the case where it is equal to, or if this was strictly less than, we would remove the endpoints and just use parentheses there. So again, remember this is an and inequality. Even though the word and is not there, the overlap has already been done for us. So anytime we have less than or equal to with an absolute value inequality, we're going to rewrite it as that and inequality. Then we will solve that compound inequality and go ahead and graph the solution set. Now I like to start out with a graph as well, just to help me to understand what inequality I'm writing. The first graph that I draw is not going to be the solution set, it's just going to help me get my inequality statements. All right, we'll look at two examples in this video. The first example, absolute value of 5x minus 6 is less than or equal to 4. I have that written here. Now I'm going to draw a graph to help me understand what this statement means. So this means that the absolute value of this expression is either equal to 4 units away from 0, or it's closer to 0 than 4 units away. So the two values that are 4 units away from 0 are 4 and -4. I can be equal to 4, -4 because I have the equal sign here. So I am thinking about including these two endpoints. But since my absolute value of this expression can be closer than 4 units from 0, I'm including all of the values that live between -4 and 4, which tells me that this expression 5x minus 6 has to be between -4 and +4 or equal to both of those endpoints. So this graph helps me to write my compound inequality. So -4 is less than or equal to 5x minus 6, which is less than or equal to +4. Right, I'm getting this inequality from this picture. I'm shading in the values that work for that expression. Now I will find the values of x that make this statement true. For this kind of inequality, I want to isolate the x in between the inequality symbols. So I will add 6 to all 3 sides. Here I have 2 is less than or equal to 5x, which is less than or equal to 10. Divide by 5 3 times. 2/5 is less than or equal to x, which is less than or equal to 2. So this is my solution set. If I want to graph my solution set, I have 2/5 and 2. 2/5 is smaller. They both are included, so I have brackets at each of them. This is an and inequality. I'm shading in between. So this represents the values of x that make this statement true, and this statement is equivalent to our absolute value inequality. We can also practice writing this as an interval. 2/5, comma 2, with brackets around both of them. All right, let's take a look at our second example. The second example, we had 4x minus 5 in absolute value is less than 3. So once again, I'm going to draw a picture of what this means first to help me set up my compound inequality. So the absolute value of this expression has to be closer to 0 than 3, or -3. So here's 0, here's 3, here's -3. The distance that this expression is from 0 has to be less than 3 units away. So what that means is that I'm not including 3 and -3 in my in the values that this expression can be equal to. I want to be careful not to say solution set because I'm not looking yet at the solutions. So I have parentheses around those. I'm shading that in between, but that's where this expression 4x minus 5 lives. So that means that 4x minus 5 is between -3 and 3, but not including those endpoints. -3 is less than 4x minus 5, which is less than 3. I'll solve that inequality, adding 5 3 times. So I have 2 is less than 4x, which is less than 8. Now I'll go ahead and divide by 4. Do it 3 times. Simplify, so 2/4 is the same as 1/2. 1/2 is less than x, which is less than 2. Right, so this is my solution set. So I'll graph my solution set. And between 1/2 and 2, not including 1/2 and not including 2. Parentheses at each of them, and we're shading in between. And if I want to write that as an interval, I could use my graph to get my interval. So parentheses, 1/2, comma, 2, parentheses. And once again, that means that the values of x between 1/2 and 2, not including 1/2 or 2, all the values in between, would work for this compound inequality, and this compound inequality is equivalent to this absolute value inequality. In the next video, we'll look at the case of greater than or equal to.